All right, so we're going to take a look at absolute value as a piecewise function. And again, there are two ways that we could do this. I think maybe algebraically might be faster, but I'll let you guys decide. So let me show you the algebraic one. So if I had the absolute value of -2, right? Oops, not a bracket, not a parentheses. That answer will be 2 because it always takes whatever is negative and changes it to positive. If I took the absolute value of 2, it would also be 2 because it's already positive. So we know that absolute value looks like a V, correct? And it is never negative. No matter where it is never negative because whatever was negative, by taking the absolute value, it was changed to positive, right? So that's the idea behind it. Now that you know that, let me go ahead and show you the algebra. So that's saying this answer right here could have been either negative already or positive. And so because I don't know, we're going to go ahead and do both. So the positive part of it will just be what it is. So 2 minus 2x. And then the negative is just the negative outside, and you distribute that. So that's going to be -2. And then a negative times a negative is a positive. So this is -2 plus 2x. Now, the big thing is to find out where this v occurs, right? Like, where is this line right here? And you can do that algebraically by solving it. So if we set 2 minus 2x equal to 0, you can find where it actually where the v occurs. So let's go ahead and move -2x to the side. It's going to be 2 equals 2x. Divide both sides by 2. You're going to get x is equal to 1. So this happens at 1. Okay, now you just need to know where is the positive side of it, where is the negative. So if I was to graph this, all right, all right, it's a negative, so I'll rewrite this in y equals mx plus b so you guys don't get lost. Mx plus b, and this is y equals -2x plus 2, right? Okay, so what does that mean? That means I start at 2 as my y-intercept, right? So let's take a different color. All right. All right, so I start at 2. And I put a point right there. Then what do I do? My slope is down 2, right 1. So down 2, right 1, down 2, right 1, down 2, right 1. So it looks like this, right? And that makes sense because we already worked it out that it was going to be at 1, right? But remember, absolute value cannot be negative, which means all of this part of the graph gets reflected back up. So what does that look like? If it's down to right 1, it's going to be up to right 1. Up to right 1. Like that. So this is actually the absolute function. So everything less than this point, everything less than here was the positive value. Okay, so this positive one is really less than. And then the negative part of the graph was greater than 1. Now, one of them has to set equal to. It doesn't matter which one, so I meant that one. Okay. All right, so let's go ahead and put that in and see if we're correct. So 2 minus 2x. And then here is -2 plus 2x. And this is for values that are x is less than or equal to 1. And this one is x is greater than 1 strictly. All right, so that's the algebraic way of doing it. So you could do it that way, or you could do it using transformation. So I'm going to show you the transformation ones a little later. Let me do it algebraically again. So remember, absolute value, you could have the positive side of it, which is going to be just exactly what it is. And I'm just going to type it out here so we can save time. Or you could do it with, you could have added the negative. So remember, absolute value of -2 is 2. Absolute value of 2 is also 2. So you can have the negative function of it or the positive. So the positive is just what it is. The negative is you just put a negative outside and then you distribute it in. So it's going to be -x plus 6. So -x plus 6. All right, now you need to find out where it happened. So initially, when this graph first started, it was a straight line. Then whatever was negative was reflected up. And you need to know whether that was greater than or less than whatever the number is. To know that, we could do a couple of things. We could solve it. So you have 6 minus x and set it equal to 0 and solve it that way. If you move negative x to both sides or add x to both sides or however you like to think of it, you're going to get x is equal to 6. So what that means is that x right here is something to do with 6. Okay. Now I need to know which side of the graph is greater than and which side of the graph, I miswrote that, is less than. And that's where you can do one of two things. Actually, you just do it with the graph. All right. So think about what this graph looks like. And my y-intercept is going to be 6. So I need to have enough of those. All right, so again, let's go ahead and write this equation in y equals mx plus b so we can see where it is. So y equals mx, the one attached to the x, right, is going to be negative x, and then b is plus 6, okay, because it's positive 6. All right, now that I know that, again, to graph this, I start at 6. So 1, 2, 3, 4, 5, 6. And then I'm going to go invisible 1, down 1, right 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 1. Boom. All right, so this is my line. I'm so sorry, it's so crooked. So it's because these are not equal. So it crosses right here. Okay, so I'm imagining that's going to, if I did this correctly, it's going to be 6. 1, 2, 3, 4, 5, 6. It is. So this part of the graph, the one that comes down, is positive, and the one that's on the negative side is the one I'm flipping over. It's the one I flip over because it's absolute function. So this graph that comes down is the graph 6 minus x, because that's what I was graphing. So this one right here is the one that's positive. And what part of that graph, where does that graph lie? It's on the left of 6, and that's what you put here. So it's on the left of 6, and remember, one of them has to have the less than or equal to, and the other one not to. All right, so that means this one was the one that was negated. All right, I think I'll do one more just so that you can completely be used to it. I think that one kind of looks like the same. Look, yeah, let's do one of these. This one is different. All right, so again, sticking it with the algebraic way of doing things. All right, so again, you can start off with the graph 2x plus 14 as is positive. So 2x plus 14. And then the negative part of that one would be if you had a negative outside. Oops. If you had a negative outside and you distribute that in, so it's negative 2x minus 14. So negative 2x minus 14. All right, for all values of x such that, so I know where the absolute value happens, whether v happens or the vertex of the absolute value, is when this is equal to 0. X plus 14 equals 0. So go ahead and subtract 14 from both sides. So you're going to get 2x is equal to negative 14. Divide both sides by 2. You're going to get x is equal to negative 7. So it happens at negative 7. And this is the only hard part, is figuring out which part is which. Now you can kind of memorize this too, because for all negatives, how do I say this? Like, okay, without me actually growing the graph, I already know that this graph is going to be positive because the slope is positive, right? It's going to start at 14. So let's say 14 is somewhere here, and it's going to do this. So I know it's going to cross at negative 7, which makes sense because you see it that way. This part of the graph is the part that's reflected back up like that. And this part is to the right. So I just need to figure out this part on the right is the positive side. So that part is greater than or equal to negative 7, because that's the positive part of the graph. This is the negative. So the positive part of the graph is the part that's on the right-hand side of negative 7. So again, I can say greater than or equal to, And then the left-hand part, this part right here, is the negative portion of the graph, which is this negative. So less than 7. And I think that's honestly the fastest way to do it. We can also do it as we did it in our notes. This to me takes a little bit longer, but I do want to show you so that you can have choice. Okay, so that's one way. Here's another way. We can start by graphing the absolute value of x plus 5, which we know is the line y equals x plus 5, right? All right, so I graph starting at 5. And then what does this mean? Rise 1, run 1, rise 1, run 1, rise 1, run 1. So it's going to do the same thing both directions. Okay, and this is not as straight as could be, but I'm going to give it my best shot. Now, that's the line y equals x plus 5, but we know what does the absolute value function do? It takes the negative portion of it and reflects it over the x-axis. So this point is going to be this point. Or it's going to be this line, right? So this is the absolute value. Now, we know what do we do with piecewise? We write both pieces, right? So we've got this line, which goes on like this. Okay, and we've got this line. So what is this line? So this line in red is y equals, my slope is down 1, right 1, down 1, right 1. So that's going to be negative x, and it crosses at negative 5. And then this positive one, which is the line I graphed, is y equals positive x plus 5. And what do you notice now? You notice that it's what we're doing algebraically. It's exactly the same thing. So there's the positive side and there's the negative side. And that's it. So you can use the graph paper. So this is y. Let's do the positive one, equals x plus 5. And then let's put the negative one, y equals negative x. Oh, why am I putting an equal sign? I'm tripping, y'all. Negative x minus 5. All right, which is exactly what we did algebraically. And then we've got left and we've got right? So this is my cutoff point right here. And this one is less than negative 5. So that's the negative one for all values of x, which is less than negative 5. And this one on the positive side is to the right? So for all values to the right of negative 5. So for all values of x greater than or equal to negative 5. Because remember, if one has to have the equal to part of it. And that's how you do it if, using your notes. So it's kind of like, it's up to you what you want to do. Whatever you find is easier. I'll just do one more. So here's another one. All right, so again, we start by graphing it. So I'm going to graph the first one, y equals 1 minus x, right? So again, writing that in y equals mx plus b, this is negative x plus 1. So it's invisible 1 over 1, starting at 1. We're going to go down 1, right 1, 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 like that. So this is the positive side of it. And then, of course, we're going to reflect this negative part to go this way, right? So if I went down 1, right 1, it's going to be up 1, right 1. Like so. Up 1, right 1, up 1, right 1, and so forth. And again, to know this line, I have to keep going so that I can see where it crosses the y. All right, so let's go ahead and write this equation for this side. So this is when we split it up. This is y equals, again, it's down and left, right? So how do we say that? Negative 1 over negative 1x, and it crosses at negative 1. When you simplify this, a negative divided by negative is a positive. So this is going to be y equals x minus 1. So those are my two equations. And then my cutoff point happens right here at 1. All right. This side to the left is that. And this side to the right is that. So now we just write down the equations. So the first equation on the left, I have 1 minus x. On the right equation, I have x minus 1. For here, I need to use less than. Okay, so it's x is less than. What number is it less than? And I'll do less than or equal to. It's less than or equal to 1. And here, I need to use greater than. So x is strictly greater than 1. So you can use graph paper and do what we did in our notebook, or you can do it algebraically. Just however your brain kind of processes it, is fine. It works both ways. All right, so go ahead and practice, and then let me know if you have any issues at all.